Well, one of the projects I'm particularly interested in is the one associated with the thermal imagery. So, given all of the predictions about global warming, our rivers are going to continue to warm. Salmon's a cool water fish. This is potentially not very good news for salmon. So, important that we understand the sort of thermal maps, the existing habitats and the critical habitats where fish can find refuge during periods of high temperature stress. This project's making that kind of opportunity or those kind of data available through the input of the different partners. So that's great. That means that we have an opportunity here to sort of provide the basis and the information, the data, so that we can protect, first of all, identify those habitats, protect them, and so ensure conservation of the species when they undergo some of these stressors like high temperatures.
So we have our thermal mapping that we're doing within the river itself to tell us the temperature of the river. And we're doing the LIDAR imagery across the landscape to give us very detailed topography for the system. And then the third technology that we're going to try is topobathymetry, which is actually a map of the bottom of the river. So we have new laser technologies now that can actually penetrate the water and build another high detailed map of the bottom of the river. So that helps for us to understand the connectivity within the river itself, so we can now see how much water is there, the temperature of the water, and whether or not fish, for example, can move from one pool to the next pool in certain water levels. So the climate is changing, and it is warming up in this particular part of our world, and that means that our rivers are warming up. And for a cold water fish like a salmon, that's where we get into issues of whether or not they have enough habitat. So everything we can do to protect that habitat, to make sure that they have all of the thermal regimes that they need throughout their life cycle. That's what we're trying to do here, is we're trying to understand it better so that we can say, okay, how do we best protect it into the future?
My name is Antonio Sullivan. I'm a PhD candidate at University of New Brunswick in Fredericton, and I'm looking at river temperature. So what we're trying to do is link landscape variables to river temperature and how they influence river temperature. So we're going to be using thermal infrared imagery for the entire watershed. And what we're going to do is couple that with remotely sensed data and other data, so things like digital elevation models, geological maps, superficial geology maps, and we're going to construct things like solar radiation exposure maps. And what we're going to do is try to link these landscape variables to the occurrence of cold water in the watershed. I think this is a unique project in the sense that we have both academia, industry and government working together on this. And the nice thing about it is the research will bring it to a certain point, and then industry can actually apply it. So rather than it stopping just at research, it goes further and it actually percolates into the community, and hopefully there'll be a benefit to the ecosystem.